video, we're going to learn about dilations. So when you hear the word dilation, what do you think it is? Any idea? Hopefully, you're thinking of eyeballs. Okay, so when you go to the eye doctor and they dilate your eyes, they're going to make your pupil really, really, really big. Okay, here's also an example of some dilations. You've got that little bitty 100-calorie Coke can, and then you've got the big Coke can. So there are dilations of each other. And then also you've got this little toy car, and then obviously looks like a maybe Maserati, no, Mustang, something like that. So you've got a big shape and you've got a small shape. So that's what dilations are. Okay. So let's take some quick notes. So a dilation is a transformation. So again, everything we've been doing is called transformation. It's just that broad word for moving a shape that produces an image that is the same shape as the original image, but it's not going to be the same size. So it's the exact same shape, so it's going to be a triangle. It's just going to maybe be a smaller triangle or a larger triangle, okay? So a dilation is similar to the original figure. So we've done, reflections and translations, which those were congruent. So I moved a triangle somewhere else. I didn't change the shape of it. It's still a triangle. It's still the exact same size. So those were congruent. But dilations are going to be similar, okay? So dilations are centered around the origin unless otherwise stated. So we're not going to go into otherwise stated. We're going to center everything around the origin, okay? So to find the scale factor, what you do is you find the original image and divide it by the pre-image. Now again, pre means before, okay? So actually you're going to take the new image and divide it by the before image. And that's called a ratio. Okay? Ratio is typically a fraction or a whole number. Okay? So if the scale factor is greater than 1, it's going to become larger. If your scale factor is between 0 and 1, so it can't be negative, it's typically going to be a fraction, it's going to be smaller. So if you had 3 over 4 as a scale factor, your shape would get smaller. But if you had 5 over 4, that shape would actually become larger because it's a bigger fraction, it's bigger than 1. Okay, so here is the rule. Again, it's similar to translation. You've got x comma y with an arrow, and then f of x parenthesis and y, or f of y, where f is the scale factor. So for example, you're always going to have this x and this y. So example 1, if the scale factor is a 3, how would you write the rule? So first off, you're going to write x comma y with an arrow. And then your scale factor is the f, so it goes in front. So you'd say 3x comma 3y. So again, that's how you find the rule. The scale factor always goes in front of the x or the y. Okay? All right, example 2. Triangle ABC has vertices 0, 2, 4, 4, and negative 1, 4. What are the vertices of its image with a scale factor of a 4? So I'm going to enlarge this shape. I'm going to make it bigger. So first off, let's say A is going to start at 0, 2. So what's going to happen, again, we're going to have that new image called A prime. And I need to multiply everything by a 4. So basically, I'm going to times by 4, times by 4. So 0 times 4 is a 0, and then 2 times 4 is an 8. So that new A prime would go to a 0, 8. Okay? Same thing for B. B was at 4, 4. So if I times everything by 4, B prime is going to be 16, 16. And then C was at negative 1, 4. So if I times everything by 4, my C prime number will be negative 4, comma 16, and then you just would have to graph the shape, okay? So that's how you implement a scale factor on a set of ordered pairs. All right, next page. So in example 3, we've got quadrilateral PQRS with those vertices, and we're going to dilate it by a scale factor of a half. So I would expect my image to get smaller since 1/2 is smaller than 1. So let me go ahead and graph PQRS. So go ahead and press pause and please graph these points on this graph. Now I've graphed this image, I need to dilate it by a scale factor of 1/2. So first off, let me go ahead and say that my new P prime image, I need to multiply everything by 1/2 up there. So that's the same as dividing it by 2. So -2, let me go ahead and show you this part. So if P is at -2, 4, I'm going to divide everything by 2. So my new P image is going to be -1, 2. That's my new P prime. So same thing is going to happen for Q. My Q prime, I'm going to do 4 and a 4 and divide it by 2 and get 2 and 2. R prime, we had 4, -2. So when you divide each of those by 2, you would get 2, -1. And then lastly would be S prime. So divide each of those and get -2, -2. So again, you can show your work or you can kind of do it in your head. But once you get these new images, you're now going to graph that, okay? To double check to see if we're right. So P prime was at -1, +2. Q prime was at 2, 2. R prime was at 2, -1. And then -2, -2 is S prime. So I can see part B, it wants to demonstrate that these quadrilaterals are similar by comparing the ratios of lengths. So I need to look at some lengths of the original PQR and then my new PQRS. So instead of doing the distance formula with those longer sides, let me take a look and see how long PQ is. Okay, so let's find the length of PQ. 1, 2, 3, 4, 5, 6. So PQ had a length of a 6. Okay, and then QR had a length of 1, 2, 3, 4, 5, 6. Okay, so if PQ and QR had a length of 6, and I want to make sure that my ratios are similar, I need to make sure my sides decrease by the same number. So to do that, let me find P prime, Q prime, and let's find that length. So from P prime to Q prime was 3. And then from Q prime to R prime was 3. Okay, so if you notice, if we go from the larger image to my original image, I get 2. Okay, so they were basically dividing by 2. If I look at my new image and get 3, and the larger image was a 6, that's going to give me a scale factor of 1/2 where they're coming from. Okay. Because remember on the front page, you had to do your image length divided by the pre-image, okay? So it's kind of confusing that since this is our new pre-image, but again, pre-image was before. So to find your scale factor, you do the new image divided by the larger image, okay? So if I look, I know that this shape is multiplying by 2, or I can look and see that this outside shape is multiplying by 1/2 to give me this one, okay? All right, now they're similar if they have the same ratios. So I know that 6 went to 3 is the same as 6 going to 3 because these sides matched up, okay? All right, lastly on this page, what do you notice about the angle measurements of the two figures, okay? So notice how this S angle and this S angle, they look the same, they look acute. Look at this right angle up here. I know they're right because they meet at a 90-degree angle. So Q is still a 90-degree angle. Look, it is right here, okay? So when you dilate something, they are the same. So the angles are the same. However, are their side lengths going to be the same? No. So just because you are making a shape larger or smaller, their angles are not going to change, okay? So dilations change the size, but not the angle. Okay, so dilations are not congruent, but they are similar. They're going to have the same angle length. Okay. All right, moving on to our next example. Example 4, if the scale factor is 5/2, how would you write the general rule? So let's answer that question first. So again, our general rule is x comma y with an arrow, and then I need to put that scale factor in front of the x and the y. So I'd say 5/2x, comma, 5/2y. So that's going to be the rule. Now to figure out if it's an enlargement or a reduction, again, enlarge means to make larger. Reduction is when you make something smaller. So we have to see if that number is over 1 or between 0 and 1. So 5/2 we know is greater than a 1, so that's going to be an enlargement. And you can say because the scale factor is larger than 1. Okay, so if you did maybe 1/2, that would be an example of a reduction because that scale factor would be smaller than a 1. Okay, all right, example 5. Quadrilateral A prime, B prime, C prime is a dilation of quadrilateral ABCD. Find the scale factor and then classify it as an enlargement or a reduction. So I am going from this big A prime, or this big shape ABCD, to this newer shape here. So one, I can notice it got smaller. So we're going to say it's a reduction. We can actually see that that shape got smaller. Now to figure out the scale factor, you need to, 1, it's going to be between 0 and a 1 because it got smaller. Then you need to pick your favorite points. So I'm going to start with B. So I need to look at B. B was at 0, 6, and then B prime was at 0, 2. So basically you're going to ask yourself, how are you going to go from a 6 to a 2? Okay, obviously we can divide by 3, but scale factor is a multiplication, it's a fraction. So if you divide by a third, that's the same as timesing by a third. Okay, so again, to find your scale factor, you're going to take the B prime and divide it by your original. Okay, so for example, I would do 2 divided by 6, which is 1/3. Okay, we can also check it with another point to make sure. So let's look at this point A. My A was at 6, 0, and my A prime is at 2, 0. Okay, so again, take your A prime and divide it by your original image, and you would get 2/6, which again gives you a third. Okay, so the hardest thing is not saying, oh, the scale factor is a 3, because I can see that they're dividing by 3. So again, dilations are multiplication, not division. So if they're dividing by a number, they're going to be multiplying by a fraction. Okay, and our answer makes sense because a reduction is a fraction. All right, last example. All right, XYZ is graphed below. Draw and label x prime, y prime, z prime after a dilation of a scale factor of a 2. So why don't you go ahead and scale factor this image by 2 and give me the new points of x prime, y prime, and z prime. So press pause and try that on your own. What I did is I first wrote down my x, y, and z points, and then I times everything by 2 and got my new prime image. I graphed it and I got this picture. Okay, and it's okay if they overlap. It doesn't have to 100% not overlap. All right, why don't you go ahead and answer this question on your own. Press pause and then we'll go over it. You're gonna have to do a reflection. Was, what are the coordinates of y double prime after a reflection of x, y, z prime over the x-axis? So first off, I drew a line on the x-axis, and then you had to flip this or the prime image over that. Okay, so we're ignoring that x, y, z. So again, reflect x prime, y prime, z prime over this x-axis, and then my coordinates of y double prime would be -2, -4, not 5. Okay, so you can do multi-steps, just make sure you put double prime if it's a second image, okay? So now you're more than welcome to practice and work on your IXL or paper copy.